Eighth graders, it's Mr. Schmidt here again with video number 5, I believe it is. This time we are talking about Newton's laws and forces and interactions. There's a lead-in video that I want you to watch about forces in outer space. So it's with astronauts. There's an IXL there that's really short. One of the things to remember when you go into the IXL G8 is when you have two forces, you always have to have two forces. And if you take a look at this first question, Kristen's foot is pushing on her cat's gas pedal. According to Newton's third law, every action has an equal and opposite reaction. So what force must be happening? Well, if Kate's foot is pushing on the car's gas pedal, then the gas pedal has to be pushing on Kate's foot in order for that to happen. Okay? Woohoo! So just keep that in mind. If it's a pull by one thing, it's a pull by something else. If it's a push by one thing, it's a push by something else. Kind of keep that in your mind and consistency as you go through. Should be fairly easy for you to catch on to with those types of things. Ask a question about forces. What is a force? What defines a force? And how does force affect motion? Why do we have to have forces enough in order, for us to move in any sort of direction? The next one there, as we're getting warmer outside, talks about slip and slides. And how does the slip and slide actually work? Well, it has to do with friction. And friction, we have friction against all kinds of things when you're sitting in a chair, when you're walking, when you're on a slip and slide or a slide at the pool or whatever it might be. When you're sliding in baseball or softball after a ball or into a base. But what is friction and what two things affect friction? And then number 5 there, the more friction, the easier or harder it is to move something. So highlight which one there is correct with that. And then just simply explaining to me, how does that slip and slide work? Okay. How exactly does that slip and slide work? And then we have a little bit more of an understanding when the weather gets nice. Okay. The next one just talks about necessarily what is Newton's third law, and then name one way that it affects you. How does it have an effect upon you? If every action has an equal and opposite reaction, how does it affect you? One way that I can tell that it affects you in a different type of way is if you put work in to get your schoolwork done, you're going to get smarter along the way, and you're going to become more disciplined. And when things get tougher in life, in different situations, you're going to be able to press on and handle those things because you've been able to handle the things that have been put out to you during this time. So the next one there, balance forces, unbalanced forces, force and motion. So the unbalanced force video there talks about a FET. We've done some FETs before. They're simulations. So if you would like to click on the FET and go through the FET yourself or play around with it, a lot of you like to do that. We did some things of that with some different things throughout the course of the school year when we were together. And so you have an opportunity to have some access to that as well. If you would then answer the questions there. What is a balanced force? And then when an object has balanced forces acting on it, what happens to it? So if balanced forces are acting upon an object, then what's happening to that object? Okay. What is an unbalanced force? And then when an object has unbalanced forces acting on it, what's happening to that object? Where is it going? What's it doing? So on and so forth. And then calculating net force. There's a teacher that I came across that did a really good job of explaining how to calculate net force. And so go ahead and watch her explain that. If the forces are being applied to an object, forces that are being applied to an object are going the same direction, How can we calculate net force? And if the forces are being applied to an object going in the opposite direction, how do we calculate net force? And so if you take a look at the board here, if a 10 Newton force and a person's pushing on this box with 10 Newtons and another person's pushing on the box with 5 Newtons, we would then add those together. So the total net force against that block would be 15 Newtons. If we have forces going in the opposite direction, let's say we have one person over here that's pushing with 5 Newtons of force and a person over here that's pushing with 10 Newtons of force. Now we have unbalanced forces that are coming at it. And when that happens, then you're going to subtract these two, and when there's a net force of 5 going to the left here, acting on this box, because this is a greater force coming across this way. If this one here was to be 10, and this one here was to be 10, then when there would be balanced forces that would be acting upon that, and that thing would essentially be going nowhere. Okay? If you stand in one place, then you're pushing on the ground at the same force that the ground is pushing on you. But if you want to start moving, then you need to push on the ground with a little bit more force, and it'll push back on you with that same amount of force to get you moving or running or whatever that might be. Okay. Next, speed and velocity as you're getting into driving. Some of you driver's ed, your permits, speed and velocity. What's the difference? We've talked about it earlier this school year. So you have to think back on that and then go into this here. And then what is positive acceleration from driving a car? Okay. So what is positive acceleration? So how do you gain positive acceleration when you're driving a car? In other words, what's an example of that? And what's negative acceleration when you're driving a car? How do you do that? Hopefully you know how to do not just number 16, but hopefully you know how to do number 17, especially if you're doing number 16 too much and you meet up with a police officer. Hopefully number 17 helps you out there. And then a checking for understanding, asking some questions as it relates to balanced and unbalanced forces. And then I have one there at the end. I'd just like to know what you're looking forward to this week. There's been a lot of things that you've done. We have our homeroom meetings on Tuesday. And next week, I'm going to have a lab that I'm going to throw out there to you guys that we'll be able to do together if you choose to tune in on that. But I'm always at a mixed feelings when I make these videos because I want to be in person with you guys. I don't like to make these videos for the sole purpose of just hearing myself talk. I want you guys to do the very best you can to be warriors and to make it a great week. So with that, make it a great week.